So in our last class, we were playing around with Möbius transformations. They're these linear functions divided by linear functions, right? And by tweaking the constant parameters a, b, c, and d, we could get Möbius transformations to behave exactly like the generators of the rational tangle group do. We could get them to satisfy the relations in the rational tangle group. We could find a Möbius transformation which, when we compose it with itself, gives us the identity function. And we could find a combination T and R, which when we compose those together, it has order 3. So we have to compose them together 3 times before we get the identity. And so in the activity, we found a couple of different possibilities. And I'm going to write these down on my whiteboard here real quick. The rotation element in our rational tangle group needs to have order 2. And so we were looking for a Möbius transformation that had the property that when I compose it with itself, when I apply the Möbius transformation, then I do it again, the result of that composition should give me the identity function, e of x equals x, right? And what's cool about Möbius transformations is that we could do that investigation by composing functions, by composing this function with itself, which when I rewrite it, this is just the function that we're going to call today little r of x equals minus 1 over x. It's the opposite reciprocal function. So I could compose that with itself. If I take the opposite reciprocal of any real number, that result is going to give me that same real number back at the end of the day, right? You can check directly that r of x, that's minus 1 over x. And when you simplify that out, we just get x, which was our identity function, right? The formula for our identity function, e of x equals x. But the cool thing about Möbius transformations is that we could also have done that at the level of the matrix 0, minus 1, 1, 0 by multiplying it by itself. And you can check that when I multiply that matrix by itself, I get the identity matrix, and the identity matrix stands in for the identity Möbius transformation, right? The identity function in the group of functions under composition. So this r of x, this opposite reciprocal function, is what we're going to use as our order 2. It's going to represent the rotations in my rational tangle group. And so the degree of difficulty of finishing up the last exercise is that we found a matrix which could stand in for not t, but for tr, right? And tr is this thing which we wanted to have order 3. Tr, the quantity to the third power, is equal to the identity. And so we can check that if I take that matrix and raise it to the third power, when I raise that matrix to the third power, I don't quite get the identity. It looks like I get the opposite of the identity. So just to play around with this a little bit more, so if we play around with our Möbius transformations a little bit more, we can find other examples of Möbius transformations who are not the identity themselves, but whose cube is the identity. So it's a functional cubed root of the identity. Here's an example, 1, 1, minus 1, 0. So I just had my minus sign in the wrong place here. So it turns out that this matrix, when I raise it to the third power, doesn't quite give me the identity matrix, but it gives me a matrix which represents the identity Möbius transformation. Right? If I turn this into a Möbius transformation, minus 1x plus 0 over 0x plus negative 1, if we simplify that out, we get minus x over minus 1, which again is just x, the identity function, e of x equals x. Right? So the question that we're trying to answer here at the end of the previous activity is, now that we know this order 2 element in my group of functions, and I also have this order 3 element, tr, which means twist and then rotate, so r of t of x. And we have a formula for it that's given by this Möbius transformation up here, so it'd be x plus 1 over negative 1, right? So now we just have to figure out how to figure out what t of x is from this information. And so to do that, I think the easiest thing to do is to remind ourselves that this function r of x is invertible, and in fact its inverse is itself, right? Because when I do it twice, I get the identity function back, right? So this is a function whose inverse is itself. Its graph is symmetric across the diagonal line y equals x. So r inverse has the same formula as r does. And so if I know that r of t of x has this formula, then I should just be able to apply r inverse to both sides inverse, because R inverse is a function, so I can apply it to both sides of an equation, and the equation remains true. But R inverse has the same formula as R does, and so my right-hand side here, R inverse of x plus 1 over negative 1 is going to be minus 1 over x plus 1 over negative 1, if that's more or less legible. And I simplify that out. It's the opposite reciprocal of x plus 1 over minus 1, and that's going to be 1 over x plus 1. And so if that would be how we were going here, then we would get a formula for my twist function, my t function, which is t of x equals 1 over x plus 1. It's not exactly what we ultimately are going to want, because it's not the easiest choice. It's not the simplest choice possible, right? In the activity last week, you and your group came up with a lot of different examples of order 2 Mobius transformations, square roots, functional square roots of the identity, as well as order 3 functional cube roots of the identity. And so some of them are going to give us nice answers. Some of them are going to give us answers that, while they will still work as a representation of the tangle group, they may not be the simplest that we could choose. And so what I'm going to take the luxury to do is to make a slightly different choice. So ultimately, where we want to be, right, is we want to have some function which represents our twist, some function which represents the rotation. The twist has infinite order, the rotation has order 2, and their composition, TR, which is R followed by T, right? It'd be T followed by R, that composition has order 3. And since there's a lot of different choices we could make, and we want to have one that we can all sort of agree upon moving forward, we can check that one of them that we can all agree upon is the choices that we see here, that we represent the twist by adding 1, t of x equals x plus 1, that has infinite order. We represent the rotation by the opposite reciprocal function, minus 1 over x. And we can check that if we do r followed by t, that's going to give me a function which, when you compose it with itself 3 times, gives me the identity function, e of x equals x. Right? And so that's where the story resumes for today.